All right, so are you ready to dive into one of those, like, what-if scenarios about the Earth?
Always up for a good thought experiment.
Okay, perfect. So today's deep dive gets pretty wild. We're going to be exploring what would happen if the Earth suddenly stopped spinning.
Ah, a classic.
Yeah, and it's all based on this educational video script I found. It's pretty mind-blowing, actually.
Yeah, I can imagine. I mean, we're constantly hurtling through space at over 1,000 miles per hour thanks to Earth's rotation.
I know, right?
Yeah.
Like right now, we're just sitting here completely oblivious to the fact that we're basically on a giant merry-go-round.
It's one of those things you don't really think about until someone points it out, and then you're like, wait a minute, what?
Exactly. And this video script really does a great job of pointing it out and then like take you down the rabbit hole of all the crazy consequences.
Okay, well, I'm definitely intrigued. So where do we start?
Well, I guess the first thing to wrap our heads around is that Earth's rotation isn't some like new phenomenon. It's been spinning for billions of years.
Yeah. Oh, yeah.
Right.
From like the very beginning of the solar system when all that gas and dust was swirling around and eventually clumped together to form the planet.
Exactly. So it's like this ancient cosmic dance that's been going on for eons.
And I'm guessing this video wants to know what happens when the music stops.
You got it.
Wow.
What happens if someone suddenly yanks the plug on Earth's rotation?
Okay, yeah. I can see where this is going. So paint me a picture. What's the immediate aftermath?
Well, the video doesn't hold back. It
Yeah.
basically says, imagine everything on Earth that isn't like physically attached to the planet suddenly launched eastward at 1,000 miles per hour.
Whoa. Hold on. 1,000 miles per hour? That's like...
I know, it's insane. We're talking oceans
Yeah.
sweeping across continents, winds stronger than any hurricane you've ever seen.
Yeah, that's definitely not good.
Yeah, it's safe to say this wouldn't be like just a little oopsie.
Definitely a major global catastrophe. We're
Yeah.
talking extinction level event here.
And that's just the immediate chaos. The video goes on to explain all these long-term changes that would make the Earth pretty much uninhabitable.
Okay, well, let's hear. I mean, assuming we somehow survived the initial chaos, what else is in store for us?
Well, the most obvious change would be to our days and nights.
Oh, yeah, of course, because Earth's rotation is what gives us that cycle. So without it,
Exactly. One side of the Earth would be stuck in permanent daylight, while the other would be plunged into eternal darkness.
talk about a long night. And I'm guessing the temperatures on each side would be pretty extreme too.
You're telling me the video script says we'd be dealing with scorching heat on the day side and frigid cold on the night side, basically making most of the planet completely unlivable.
It's amazing to think that something as simple as the Earth spinning is what keeps us from these extreme temperatures.
Right. It makes you realize just how delicate the balance of our planet is.
Yeah.
And it gets even crazier when you start thinking about the magnetic field.
Oh, the magnetic field. What about it?
Well, turns out Earth's rotation is what generates that magnetic field, which acts like a shield protecting us from all that harmful radiation from the sun.
Oh, right. So without the magnetic field, we're basically sitting ducks for all those cosmic rays and charged particles.
Pretty much.
Yeah.
The video makes it clear that this isn't just like a bad sunburn situation.
Right.
We're talking levels of radiation that could wreak havoc on life as we know it. Plus, without the magnetic field to hold it in our atmosphere, would slowly start to leak away into space.
So no more days or nights, extreme temperatures everywhere, constant radiation bombardment, and our atmosphere slowly vanishing.
Yeah, I'm starting to see why this is a bad idea.
I'm with you there. But there's one more thing I'm curious about. What happens to gravity in all of this?
Oh, that's an interesting question. Let me think for a second. Well, actually, Earth's rotation does play a role in how we experience gravity.
Wait, really? I never knew that. How does that work?
It's all about centrifugal force. You know, like when you swing a bucket of water around and the water stays in the bucket?
Oh, yeah, I've seen that.
Well, the same principle applies to the Earth. The faster it spins, the stronger that outward force is, which slightly reduces the effect of gravity near the equator. So if the Earth suddenly stopped, we'd all feel a little bit heavier.
Especially if you're standing at the equator.
Exactly.
Wow.
That's crazy. So we've got this terrifying picture of a suddenly motionless Earth. But how realistic is this scenario? Is there any chance our planet could actually just slam on the brakes like that?
Thankfully, no. The video puts those fears to rest pretty quickly. It says that a sudden stop like that is virtually impossible. The forces needed to hold Earth's momentum would be just mind-bogglingly enormous.
Okay, that's a relief. But is there a catch?
Well, there is a twist. The Earth's rotation is actually slowing down.
Wait, what? Really?
Yep. But don't worry, it's a very gradual process that's happening over billions of years.
Billions of years.
Yeah.
Okay, that makes me feel a little better. But why is the Earth slowing down?
The culprit is our very own moon.
The moon. How is the moon involved in slowing down the Earth?
Through something called tidal friction. It's a bit complicated, but basically the moon's gravity pulls on Earth's oceans, creating tides. And those tides, as they ebb and flow, create a subtle drag on Earth's rotation.
So it's like the moon is very slowly applying the brakes on Earth's spin.
Exactly. It's a fascinating example of how everything in the solar system is interconnected.
It really is. But what I'm really curious about now is, what are the long-term consequences of this gradual slowdown? I mean, we've talked about the immediate chaos of a sudden stop, but what happens if the Earth just keeps slowing down over billions of years?
That's a great question, and it turns out there are some pretty surprising effects, but we'll save those for after a quick break.
Stay with us, because when we come back, we'll be exploring what the future holds for a slowly spinning Earth.
So you're asking about what happens as Earth's rotation keeps slowing down over billions of years?
Yeah, like what kind of changes are we talking about?
Well, one of the most noticeable changes would be to our calendar.
Our calendar? What do you mean? Like we'd have to add a few more days to the week?
Not quite. I'm talking about the length of a day. As Earth's rotation slows down, the days will get longer.
Longer? How much longer?
Well, according to this video script, billions of years from now, a day on Earth could last for hundreds of hours.
Hundreds of hours?
Yeah.
That means a single day could be like weeks long.
It really puts things in perspective, doesn't it?
Yeah. Can you imagine trying to work a 9-to-5 job when a day lasts for weeks?
It would definitely change the way we live, that's for
Yeah,
sure.
sure.
And it raises an interesting question about how life on Earth might adapt to such dramatic changes in the day-night cycle.
Yeah, I was just thinking the same thing. Like plants and animals have evolved to live in sync with a 24-hour day. What would happen if that cycle was completely thrown off?
Well, some scientists believe that a slower rotation could actually drive evolution in unexpected directions.
Really? Like how?
Well, for example, plants might develop new ways to conserve water during those extended periods of daylight.
Oh, that makes sense. And what about animals?
Animals might become more nocturnal to avoid the scorching daytime heat. Come out at night when it's cooler.
So basically, a slower Earth could lead to all sorts of new and bizarre life forms.
It's definitely a possibility, and it just goes to show how adaptable life can be. The video script also mentions another interesting effect of a slowing Earth, the gradual redistribution of Earth's mass.
Redistribution of Earth's mass. Now that sounds complicated. What does that even mean?
Well, you see, right now, Earth's rotation causes it to bulge slightly at the equator.
So it's not perfectly round.
Exactly. It's like when you spin a ball of dough, the centrifugal force pushes the middle outward. But as the rotation slows down, that bulge would gradually decrease.
So the Earth would become more spherical over time.
Precisely. And that shift in mass could have all sorts of knock-on effects on things like plate tectonics, volcanic activity, and even the distribution of oceans.
Wow. It's amazing to think that something as simple as Earth's rotation could have such a profound impact on the planet.
It really highlights how interconnected everything is, and it makes you wonder what other subtle changes are happening that we're not even aware of.
That's a good point. This whole deep dive has been pretty eye-opening. It's made me realize that even seemingly impossible scenarios can teach us a lot about how the world works.
Exactly. And speaking of learning, the video script goes into quite a bit of detail about the science behind Earth's slowing rotation, particularly the phenomenon of tidal friction.
Oh yeah, we touched on that earlier. You said it's caused by the moon's gravity pulling on the oceans, right?
That's right. But the video does a really good job of explaining how it all works. It's like imagining the moon's gravity as a giant hand gently tugging on Earth's oceans.
Okay, I can picture that.
So this tugging creates bulges of water on both the side of Earth facing the moon and the side opposite it.
Those are the tides, right?
Exactly, high tides to be precise. But here's the key. Earth's rotation is actually faster than the moon's orbit.
So Earth is spinning faster than the moon is moving around it.
Yep, so as Earth spins, those tidal bulges are constantly being dragged slightly ahead of the moon.
So it's like Earth is trying to spin away from those bulges.
Precisely. And that constant tug of war between Earth's rotation and the moon's gravity is what creates friction, tidal friction.
So it's like the moon is constantly pulling back on Earth's oceans, very, very slowly slowing us down.
You got it. And the video emphasizes the incredible scale of time involved in this process. We're talking billions of years for Earth's rotation to significantly slow down.
Billions of years.
Yeah.
It's mind-boggling to think about. But it makes you wonder what other subtle long-term changes are happening to Earth that we're just not aware of.
Absolutely. I think that's one of the biggest takeaways from this deep dive. The fact that even though a sudden stop of Earth's rotation is highly unlikely, the gradual slowing down is a reminder that our planet is in a constant state of flux.
It's like we're constantly changing, but the changes are so slow that we barely even notice them.
Exactly. And that's why I think this video script is so valuable. It encourages us to think beyond our everyday experiences and consider the vast timescales over which the universe operates.
So if you could leave our listeners with one final thought from this deep dive, what would it be?
I'd say don't take Earth's rotation for granted. It's more important than we realize. And it's a constant reminder that our planet is a dynamic, ever-changing place. And who knows what other amazing discoveries await us as we continue to explore the mysteries of the universe.
Well said. I think that's a perfect note to end on.
Yeah.
Thanks for joining us on this deep dive into what would happen if the Earth stopped spinning. It's been an incredible journey. So to wrap up this deep dive, I think the biggest takeaway for me is that we shouldn't take Earth's rotation for granted.
Yeah, I agree. It's one of those things that's so fundamental to our existence, but we rarely even think about it.
Right. It's easy to forget that this constant spinning is shaping our world in ways we don't even realize.
Like how?
Well, for one thing, it's what gives us our days and nights.
Oh, yeah, of course.
Yeah.
And it also plays a huge role in regulating our climate.
Exactly. And we can't forget about the magnetic field which protects us from all that harmful radiation from the sun.
It's incredible how much we rely on Earth's rotation for our very survival.
And even though a sudden stop is pretty much impossible, the fact that Earth is gradually slowing down is a reminder that change is the only constant, even on a planetary scale.
It's true. We often think of Earth as this solid, unchanging thing, but it's actually in a constant state of flux.
It's like we're on this incredible journey through space and time, and the Earth is constantly evolving along with us.
And who knows what the future holds for our planet as its rotation continues to slow down.
That's a good point. I mean, we've talked about some of the potential effects like longer days and changes in climate, but there could be other surprises in store.
Definitely. It's impossible to predict exactly how things will play out, but it's exciting to think about the possibilities.
I think that's what I love most about these deep dives. They
Yeah.
really spark your imagination and make you appreciate the wonders of the universe.
Me too. It's a reminder that there's always more to learn and that the universe is full of mysteries waiting to be unraveled.
Well said. So the next time you look up at the stars, remember that our planet is a dynamic, ever-changing place, and that even seemingly impossible scenarios can teach us a lot about the forces that shape our lives. Thanks for joining us on this deep dive into what would happen if the Earth stopped spinning.
It's been a pleasure exploring this topic with you.